Hey everyone, have you ever been absolutely blown away by what AI can do? It feels like magic sometimes, predicting what you want before you even know it, understanding your voice, helping doctors spot tiny details. It gives off this incredible vibe of being, well, smart. It has amazing perceived intelligence. But have you ever stopped to think about how it does all that? Does it actually understand things the way we do? Knowing why one thing leads to another? Or is there something else going on under the hood? Today, we are pulling back the curtain. We are diving into the fundamental difference between correlation and causation, and why most of the AI we interact with every single day relies almost entirely on the first one. We will show you why that distinction matters, especially in areas like your health and safety, and even touch on how the business world's drive for quick results has shaped the AI we have. Alright, let's start with correlation. Forget AI for a second. Correlation is simply about spotting when two or more things tend to happen together. Like when the temperature goes up, what else happens? Usually, ice cream sales go up too, right? They move together. This is a classic example. Ice cream sales and shark attacks are often correlated. When one goes up, the other tends to go up. But does buying a corn make sharks hungry? Obviously not. Both are simply correlated because they share a common cause. Warm summer weather. Correlation is just saying, hey, these two things seem connected. Like seeing two friends always together. They might be related, or maybe they just like the same coffee shop. AI is brilliant at finding these kinds of associations in massive amount of data, far more complex ones than ice cream and sharks. It sees patterns in numbers, text, or images, recognizing that if pattern A shows up, pattern B is also likely to be there. It's about spotting relationships, not understanding the why behind them. So, why has AI focused so much on correlation? Think of training an AI like teaching someone to predict something. You could try to teach them the incredibly complex underlying reasons for why something happens, like explaining all the physics and chemistry of weather to predict rain. Or you could teach them a simple rule. If you see dark clouds, it often rains. That second approach is much easier. Modern AI, particularly machine learning, is fantastic at learning these easier correlation based rules. It finds complex patterns. Input X often comes with Y. So, if I see X, I should expect Y. Then there's the data itself. Most of the data available in the world is simply observational. It's a record of what happened, like watching traffic go by. AI learns from observing this massive stream of events and spotting which one correlate. It's like learning about human behavior just by watching people, not by running psychological experiments. And the data AI uses is often incredibly complex. Think of millions of tiny details in an image or the nuance in human language. Trying to model the direct causal relationships between every single one of these details would be mind-bogglingly difficult. Correlation provides a way to find powerful patterns without needing to understand the underlying intricate mechanics. And the truth is, for many tasks, correlation-based AI works incredibly well. It's led to amazing predictions, personalized experiences, and efficient systems. It gives the AI that feeling of being truly intelligent because it's so good at performing these tasks based on patterns. We see the impressive outcome, the great recommendation, the relevant search result, and perceived intelligence. And here's a big driver, profit. Building AI models based on correlation is often faster and cheaper than trying to build models that understand deep causality. You can use readily available data, train a model to predict what's likely to happen, and quickly deploy it to gain a business advantage. The immediate return on investment from correlation-based predictive AI has been enormous, making it the path of least resistance and highest short-term profit for many companies. Why invest years in complex causal modeling when a correlation model can start boosting sales next quarter? But relying solely on correlation for all its speed and perceived intelligence has critical downsides. It works great as long as the patterns it learned in the past hold true. But the real world is messy and constantly changing. When those underlying conditions shift, correlation-based AI can suddenly fall. Think about self-driving vehicles. An AI is trained by observing millions of hours of human driving. It learns powerful correlations. When my sensors detect a pedestrian stepping off a curb, pattern A. Human drivers apply brakes, pattern B. It's a strong correlation and it will likely break. But what if the pedestrian is just standing on the curb, talking on the phone? A purely correlation-based AI might still break hard just because it saw pattern A. It doesn't understand the causal reason human drivers brake because the pedestrian intends to cross, which causes safety risk. It correlates pedestrian near road with braking. Instead of understanding pedestrian crossing road causes need to stop. The stakes are even higher in healthcare. Imagine an AI analyzing patient data and finding a strong correlation. Patients who take supplement X tend to recover faster from condition Y. A doctor might see this and recommend supplement X. But what if the real reason those patients recovered faster was in the supplement? What if patients who can afford supplement X also tend to have better access to healthy food, less stressful jobs, and receive more consistent medical care? Supplement is correlated with recovery, but those other factors are true. Causes of better health outcomes. Recommending supplement X based on correlation alone is not just potentially ineffective. It could delay the patient from seeking treatments that do address the root causes or waste their money. This is negligible. In healthcare, misunderstanding cause and effect can literally mean the difference between life and death or lead to wasteful and unfair health practices. These examples show that perceived intelligence based on correlation is powerful for prediction, but it's brittle when you need to understand the why or react to something new. It highlights why, especially in critical areas, relying solely on correlation is not good enough for safety, fairness, or true reliability. This is where the frontier of causal AI comes in. It's about moving beyond just spotting patterns to building systems that can ask and try to answer the what if questions. It's about understanding the mechanisms. Causal AI wants to know if I intervene and changes one thing, what will happen? It uses concepts from fields like statistics and economics, employing techniques like analyzing data as if it came from a randomized experiment, or building models that explicitly map out hypothesized cause and effect relationships. For self-driving car, causal AI could help to understand that applying the brake pedal causes deacceleration due to physics and that yielding to a pedestrian causes traffic flow changes because of traffic laws and safety protocols. For healthcare, it could help identify if a specific drug causes a molecular change that leads to recovery, allowing for more targeted and effective treatments. Building true causal AI is challenging. It's harder to get the right kind of data that shows the result of interventions, not just observations. The models are often more complex, requiring more assumptions and deeper domain knowledge to build correctly. And yes, the fact that correlation was the faster, more profitable path initially also meant less investment flowed into the harder problem of causality for a while. But researchers are making exciting progress, developing new methods to infer causal links from observational data and building hybrid systems that combine predictive power with causal reasoning. The future of AI isn't just about bigger models finding more correlations. It's about building systems that truly understand the world around them. Causal AI holds the promise of making AI not just smarter but fundamentally more trustworthy, robust, and ethical. So, the next time you see AI do something amazing, remember the secret sauce is often correlation, spotting patterns in data to create that powerful perceived intelligence. But the next big leap, the one that will make AI truly reliable in the most important areas of our lives, is the move towards understanding cause and effect. That's our deep dive into correlation versus causation in AI. I hope this made the distinction clearer. If you found this video helpful, please give it a thumbs up and subscribe to our channel for more deep dives into technology. And we do love to hear from you in the comments. What area do you think desperately needs AI that understands causality, not just correlation? Let us know your thoughts.